Hi all. Today I'm discussing about a new chapter, chemical kinetics. Chemical kinetics. Before starting this chapter, let me tell you some examples, some familiar examples. Do you know that how can we make curd from milk? Yes, we can prepare curd from milk by fermentation. How much time taken for this chemical reaction? Maybe one day or maybe 6 or to 10 hours. So this chemical reaction needs 10 hours. Another example, do you know that rusting of iron is a chemical reaction? Okay, suppose we put a piece of iron in a ground. After a few days we observe that rust happen in the iron piece. This rusting is basically a chemical reaction. How much time taken for, approximately how much time taken for this rusting process? Maybe 1 or 2 weeks. Yeah. So I conclude that by understanding both these examples, we can uh, conclude that all chemical reactions are not taking place in a same speed. Some chemical reaction taking place very fastly, some may be late. In chemistry lab, we are going an experiment in test tube in higher secondary plus 2 classes. We got results in a fraction of seconds. That chemical reaction taking place in a fraction of seconds. Okay, so in this chapter we discussed about the different types of chemical reactions based on the speed of the chemical reaction and their equation to calculate the speed and time taken for the reaction, etc. So our chapter is chemical kinetics. This headings includes two words. One is chemical and another is kinetics. Kinetics means the word kinesis. That means speed or movement. Speed or movement. Chemical means chemical reactions. So in this chapter we discussed about the speed and the movement or speed of the chemical reactions. Okay, for introducing this chapter, let me introduce one term, that is rate of a reaction. What is rate of a reaction? Rate is nothing but, this is a term common in this chapter. Rate nothing but it's a speed of a chemical reaction. Rate means speed, nothing but speed of a chemical reaction. Suppose consider a reaction. I consider a simple reaction for understanding, that is R gives P. Okay, what is R? R is reactants and P is products. Okay, the reactants converted into products. How can we calculate the speed of the reaction? We can calculate the speed of this reaction either by checking the concentration of reactants by time or checking the concentration of products by time. It's our choice. Okay, suppose mathematically how can we represent this? I write that first of all I take in terms of reactants. We can estimate the speed of a chemical reaction by decreasing the concentration of reactants by time. Yeah, are you clear? We can calculate the rate of this chemical reaction in terms of reactant for looking the concentration of reactants by time. What is the change for reactants when time passes? We know that the concentration of reactants decreases by time. However, the concentration of products increases by time. So we can calculate the rate of chemical reaction by checking both of these parameters. So in mathematically, how can we represent that? Look at the board. First of all, I take in terms of reactants. I can easily write that delta of concentration of R divided by delta T. What is this delta? Delta means change in. What is this square bracket and R? Square bracket means concentration. Change in concentration divided by change in time. Like change in concentration divided by change in time. I put a negative sign here. This negative sign indicate that the concentration of reactants decreases by time. Okay. Another way, we can mathematically represent the rate of this chemical reaction in terms of products. We can easily write it as change in concentration of product divided by change in time. Okay, it's are both are equal. It is both are equal to the rate of the reaction. Okay, it is a positive sign because the product concentration increases by time. Okay, today we discussed about the introduction part of chemical kinetics and then rate of the reaction. We can calculate the rate of the reaction by this equation, either in the terms of reactants or in the terms of products. Okay, that's all today. Thank you.